Hey guys. Is everyone able to hear me? Okay. I guess so. Hey guys. Good afternoon, good evening, good morning, to wherever you guys are tuning in from. So just to introduce myself, I'm Julian. So I'm a business development, driving business development and ecosystem growth for BSC. And today we have a really special guest with us today as part of our security workshop. So for these guys, they are like a monitoring system, and you'll be able to do basically real-time monitoring, alerting, and troubleshooting for all the kind of smart contracts that you program. So without further ado, let me add them in so that they could introduce themselves. Okay. Hey guys, so we have Bogdan. We have Bogdan with us from Tenderly. He's our very special guest. Bogdan, if you could give a slight introduction of yourself, that'd be great.
Sure thing. So as Julian mentioned, hi everyone, my name is Bogdan. I'm the CTO and co-founder of Tenderly. And I'm really glad to be here talking to all the people building on top of the Binance Smart Chain, building in the blockchain space in general, as Tenderly came to be one of those scratch your own itch type of stories where we were actually developing our own things on top of, it was only Ethereum back then, but we were missing a lot of the tooling while developing, and while building some internal tools, we discovered that we enjoy building developer tools much more than actually working on stuff on chain. And then we open sourced a bunch of stuff, people liked it, and from there on, Tenderly came to be. I think it's now 2.5 years, something like that. So today I'll be talking about a couple of things around monitoring in general and what can we learn from the normal development world and how we can even one up that and be better than them. So yeah, that's a quick intro.
Well, you pretty much summed up all your life's experiences, your work experiences, all in that quick 5 to 10 minutes. So really thankful for that. Hope everyone on the stream managed to catch what Bogdan has been doing and who he is representing today. So Bogdan, you guys do monitoring, alerting, and troubleshooting for smart contracts, right? Maybe you could share with us some of the metrics that you guys use and basically how teams can use them to create a monitoring system.
That would be great. It's one of those fake intros where I actually I have a slide deck prepared just for that. What a coincidence. So without further ado, I can share my screen and we can start.
Sure, please go ahead.
Sure. Just give me a second. So Julian, because I will stop seeing you right now, just tell me, do you see the presentation software, and then we can start.
Yes. Okay. Yes, I think I do.
Awesome.
So let me add.
That's it. Okay. It's a black screen right now with a question mark, and that's it. If you see that, we're good. We're golden.
Great. In that case, guys, I'll pass on the time to Bogdan. Bogdan, please.
Awesome. Great. So I won't do the introduction of myself again, as we already did that. A thing I didn't mention before coming into the blockchain space, my friends who I've founded the company with and I have been working in a bunch of Web 2.0 companies. So we actually had a lot of experience in building and monitoring large distributed systems. And when we came to the blockchain ecosystem, and started building our own project, we saw that things are handled quite differently. So during the lifetime of Tenderly so far, which, as I mentioned, has been around 2.5 years, we have started talking with a lot, and I mean like really a lot of teams building on top of different chains. So Binance, Ethereum, Polygon, and a bunch of other networks. And DeFi is exploding. So this is something that we can all be sure is not the next big thing, but it's actually big right now. But an interesting thing there is everybody's focusing on how much value they have locked in their protocols, how much value they're bringing to their own customers, which is all great, but with real money and usually not just millions, but actually billions of dollar value locked inside these protocols. We really need to think about the security aspect of things and not just the smart contracts are working as expected and the code is like formally okay, we also need to be sure that people aren't doing anything malicious with our smart contracts. And unfortunately, right now, and for the last 2.5 years, it has been the case where people completely ignore the monitoring side of things. And that's where Tenderly basically comes in. So Tenderly, and you'll hear more about it after the presentation itself, but Tenderly is a monitoring, alerting, and debugging solution first, where we cater to teams building on top of different chains, usually that have a virtual machine. So it's Binance Smart Chain is one of those. And we help teams make sure that everything is working as they expect it to work, and have much better sleep at night knowing that nothing is breaking and that nobody's trying to hack them. And below you can see my Twitter handle, so if you want to shout at me over the internet, that's the way to do it. So without further ado, the name of this presentation is Fantastic Metrics and Where to Find Them. And I must say, this was one of the cases where I think I actually came up with the title first and tried to make content around it, as I really like the title. But it seems that it's actually a really important topic to talk about. So cheesy jokes aside, today we will be covering 3 main topics. So the first one is, what is monitoring? And this is all from a Web 2.0 perspective first. After that, we will talk about when is the right time to actually start monitoring on your contracts, all your projects and contracts. And then finally, the third one being how to take what we know from the Web 2.0 world, how can we use that for dApps and protocols, and then even better, what we can do that the other guys cannot. So that's my actually favorite part of the presentation. And then if we have the time, I'll also show you how to set some of these things up in like less than 10 minutes on Tenderly. But then again, that's in the function of time. So we'll see if I speak too slowly or too fast. So what is monitoring? Now, when you're making a presentation, one of the first things that you do around your topic is you Google it and then go to Wikipedia and read like the official definition. And this one is like tools and processes by which you measure and manage your IT systems. And like every Wikipedia definition that's taken out of context, this means literally nothing to anyone, especially even to the people that wrote the sentence. But the 2 words from this sentence I would like to focus on is actually the tools and processes. And we'll see better during the presentation what is actually meant by that. So I think how I like to look at monitoring and monitoring systems in general is metrics generated by the system and the business value that you want to do. So I'm guessing like the first question is, what are metrics? Metrics are anything that you can measure, anything that you can save somewhere to look at afterwards. So in the normal world, a metric can be how fast a request finished, or how many API calls a certain user made. In the Web 3.0 systems, we can say, for example, how many transactions a certain address has sent, or for example, how many failed transactions do we have? And then we can do stuff with that can bring business value. And in the end, we are usually engineers building things, and we love building stuff, actually rebuilding the whole financial ecosystem on top of different networks and different blockchains. But in the end, we want to bring some business value as well, because if it's not that, we're just basically making toys. So we can focus on the 2 parts here. The first one being the business side of things, and then the second one being the system side of things. So for the business side of things, you'll see we'll talk more about what product managers like to think about, what data scientists like to think about, what business analysts like to think about. And then for system metrics, we'll see that it's something more engineers talk about, both front-end and back-end engineers, and then smart contract developers and security analysts. So without further ado, let's dive into the former part first. So what is a business metric? And we can perceive it in a couple of ways. So the first one, and then again, just to remember, we're looking at this from the Web 2.0 perspective first. It's user experience data. So this is something that can be measured. For example, how much time does it take someone to do something in their application, be it that or a normal real-world application. So it's user experience data, usually what the user is doing on the front end, what the user can feel. So the time a request takes, for example, isn't user experience data. the time it takes for a user to go through a whole flow in our app as user experience data, for example. It's used for product decisions. So as I mentioned, this is usually used by product designers, product managers, business analysts, etc. So these metrics are usually used to make decisions on what to build next, what needs to be improved, even what needs to be removed, for example, from an application. We can see that somebody isn't using, that nobody actually isn't using a particular feature, and then a product decision can be, okay, let's remove this. We shouldn't be working on this anymore as nobody's using it. So that data is used for making product decisions. And then again, this is something the user will see and something the user will use. It's used for technology investments. Again, we are engineers, we like building things. Building things takes time, and usually that time does cost some money. So the business side of making software is using these metrics to be sure if they're making the right technology investments, both from the money perspective, but also from manpower, people power side of things. As I mentioned, let's say, for example, we've built a feature that nobody's using. We should just cut it out. We shouldn't maintain it anymore. But then again, if we build this awesome thing over the weekend and we see multiple people using it, maybe we should put another team on that and make it even better. So that's using it for technology investments. So that was the business side of things. But as I'm guessing, mostly there's engineers on this call. Let's go to the system side of things, which can be much more interesting to us. So system, state of the system. Now, this one's interesting, and it's much different when you contrast it between the traditional world of software building and then the blockchain. The traditional world of building software means usually how our services, the state of our services. So for example, if something's running, if something has failed, the state of our database, so how big the database is, or how many rows we have in a particular SQL table, for example. In the Web 3.0 side of things, it's much more interesting because for the first time ever, we have this whole world computer narrative where our application is running, and in this case, it's smart contracts, but it's basically our application is running next to thousands and thousands of different applications. And we're all sharing the same state. And it's really important to take care of that little part of our state that's our own. So the state of the system, usually in the Web3 world, can be how many users have a token that we've built, or how many loads have been taken out from the system. But then again, from an engineering perspective. The next thing they're used to detect problems. So again, the business cares only if the user doesn't feel any problems. But have you ever, for example, opened up BSC scan in the morning just to see that the last 2,000 transactions have failed on your smart contract? You should definitely check if something's going wrong. It may have been that the users haven't had enough BNB to submit the transaction, but there might be also a bug in your system. So we can actually use that as a signal that we should take a closer look and see if everything is working as expected. It's used to diagnose and resolve faults. So let's see something isn't working. Great. We can use these metrics to see what actually isn't working. In the DeFi space, there's this whole money Legos analogy that's floating around that people like to use. So we have products building on top of products, building on top of products, building on top of products. So when somebody sends a transaction, they don't just touch our smart contract. They usually touch dozens and dozens of smart contracts. So if you're doing even a single trade on PancakeSwap, you will touch at least 4 or 5 contracts just to do a simple swap, nothing else. So it's really important if something isn't working that we use these metrics that we can to easily find and then resolve the faults that we've made during the development. So that was the business side of things, and that was the system side of things. Again, to reiterate, the business usually cares about what the user sees and what the user feels while using a certain product, so that's user experience data, and then how to use those metrics to make decisions on where both money and technological investment should be made. And then on the system side of things, we have more runtime level metrics, which we care about. So how much gas are our contracts consuming? Are we sure everything is working expected? And then finally, optimizing how much time we actually need to fix something. So that is like a really brief introduction on what is monitoring. This is a topic that has hundreds of books written around it, and I can definitely not cover everything just in one talk. But the thing that I usually like to talk about a lot is when to start monitoring. And this one's interesting. So there are 3 levels of monitoring, actually, when you think about it. This isn't an interactive session. I usually like asking people around if they can name all 3. And it's quite not intuitive. So let's see which 3 levels. So we have the manual one, we have a reactive one, and then we have a proactive one. So all 3 of these make no sense when you put them like this in a list. But as you can see so far, we'll probably deep dive into each one of them. So let's go with the manual first. So the manual one is actually the one we see the most in most teams. It's the easiest to start doing, but it brings the least value. So we check periodically. Imagine a case, you go to sleep, you're not sure if your smart contract is working, but somehow you manage to fall asleep as you're tired from all of the engineering. You wake up, and then you open a BSC scan, the first thing that you do, and you see a bunch of transactions failing. So we already talked about this case. This is a horrendous feeling. Some time has passed, we fixed the bug, we had our lunch, we come back from lunch, we refresh BSC scan, again, something isn't working. This is a really bad way of seeing how are things working as expected or not, but it's the easiest thing to start out doing. And this is what most teams actually do when they're starting out. What's even worse is that users usually let us know if something isn't working. So unfortunately, a lot of teams know the feeling of finding out about the bug or something isn't working as expected only when the user comes to your Discord channel and shares, hey, this particular transaction continues failing, or hey, I cannot take out the loan, or hey, my swap failed, now my funds are lost, and things like that. So this is a horrendous feeling. The worst way to find out about the bug is when the user lets you know something isn't working. And then you usually start doing this when the first failure occurs, and only for that specific part of system. So again, what that means is a user tells us that our swap function isn't working and they cannot swap one token for another, for example. Only from that point on, when we fix things, we will start refreshing BSC scan and seeing if something is working or something isn't working. This is horrendous. The more bugs people actually do report to you, you will have to check manually more parts of your system if they're working. You will get a sort of paralysis, let's call it like that, because you're building out a new feature, you don't know if something else is broken, so you constantly need to test out everything manually in your system and see if everything is working. So manual one, just to remember, it's the easiest to start doing, but the worst one when it comes to which value it brings. So the next one is reactive. And from the name of it, I'm guessing you can get like a general feel for what it means. So it's based on simple threshold. So a threshold is when a certain metric goes over a certain value. The easiest one to explain would be if more than 80% of my transactions are failing, notify me that it's not working. 80% would probably be a lot. So let's say if more than 10% of my transactions are failing, do let me know that something is happening. These are quite simple to start doing. In the normal Web 2.0 side of things, thresholds are used, for example, tell me if the CPU value goes above a certain threshold, or tell me if I'm running out of disk space, or tell me if I'm running out of file handlers, for example. These are really easy to set up. And what I tell most teams is that you should usually start with these. And they're the easiest ones to set up, and they're not manual. But we do have an improvement here over the manual approach, or even worse, that you're not doing anything, is that we see from both engineering and product side of thinking about the problem that there's some movement around using data to measure customer experience. So more than 10% of our transactions are failing is usually an indicator that our customers aren't having a good time using our dApp and are probably starting to use a competitor. Or if, for example, our gas usage goes way up, there's like a huge spike. Again, the customer experience is bad because people are spending more money than they should to call our smart contracts. So there is some movement. We are not doing anything intentionally, But just by looking at these thresholds and seeing how they interplay or connect to one another, we start getting a general feel around how our customers are using and experiencing our app. Again, similar to the manual side of things, it's that updates tend to be reactive. So when something happens, that's when we will usually add a reactive monitoring solution. So again, I'm always using the failed transaction example. So if more than 10% of transactions are failing, that was the first time we saw it. So okay, let's add an alert, notify me if more than 10% of the transactions are failing. But we reacted to the problem. We weren't proactive. So we never actually thought that something can go wrong. Only when it did go wrong, we wanted to prevent it in the future, if that made sense. And then finally, is usually the last step in application or infrastructure development and deployments. So again, what this means, it's not that we started writing our smart contracts, started writing our UIs, and we instantly thought, hey, this can fail, or hey, I really want to know how much this function is using, how much gas. I really want to get notified if the usage spikes. That's not the case. It is usually the case that we do all of the things. So we do our audits, we do our development, we do our front end, we deploy our front end, deploy our contracts and everything else. And then we think, oh, we might want to know if something isn't working as expected. So this isn't good. And that's where we actually come into the proactive approach here. So the proactive approach is your core way to managing infrastructure in the business. So a feature isn't done. A feature cannot be shipped or deployed on chain or deployed on the UI to our users if we don't have metrics and alerting around it. So a thing cannot be, I know I'm repeating myself, but a thing cannot be thought of as done unless we have all of the metrics around it that we can measure both the business value gain, but also that everything is working as expected. It focuses on measuring both the application performance and the business outcome. So in the normal world, let's say with the Web 2.0 world, the application performance would be our average response time from our server is 300 milliseconds, for example. And the business outcome is when users are using our mobile application, for example, things feel snappy and we're making more sales on our app, for example. In the Web 3.0 side of things, this means is, are we spending too much gas? That's application performance. But the business outcome is, are users using us or a competitor because it's much cheaper to use a competitor? So it's really important to marry both the business and the application and the systems side of things. Again, there is a huge focus on measuring the quality of service and what the customers are experiencing. So we are engineers, we are writing code, but at the end of the day, it's human beings using that code. And it's really important to provide the best possible experience for those people. The quality of service is usually that when the user clicks something, that thing happens. So we're sure that in our examples, the swap does happen, they get the amount of tokens back they were expecting. But from the customer experience perspective, it was also how enjoyable that interaction was. Did they have any trouble? Did they, and this is usually a thing with blockchains, and I remember especially entering the space, you know that feel when you sign a transaction on MetaMask or Ledger or whatever, and you're not sure, should have you done that? Like, is everything working? Will you be rocked? Will somebody steal your funds? Customer experience solves that by giving a peace of mind to the user in a correct way. And then finally, and this is what I mentioned, but whole products and features cannot be considered as done at all until we do monitoring. So there's no, hey, let's just ship it and we'll monitor it later. That's the reactive approach, and that's not good. The proactive approach is we cannot ship something until we know that we can see if everything is working expected and that nothing is failing and that it works like we want it to work. So again, really important, and I know I'm saying this for the third time, and if you take anything from this whole presentation is products should not be considered feature complete or ready to be deployed if we cannot measure things around them, so without monitoring. So we covered what monitoring is in the Web 2.0 world. and got brief glimpses of what it is in the Web 3.0 world. We were talking about when to start monitoring. So again, to reiterate, we talked about the manual approach, which is us just refreshing things and seeing if everything is working. The reactive approach, which was when something fails, we do add some automation around measuring things, but then again, we only reacted after it failed. And then the third one was proactive, about thinking from day one how we will measure this, how we will use this to get the business value and both the systems value extracted and be sure that our product is the best we can make it. So we are building blockchain apps. So how to monitor dApps and protocols. There are a couple of things. The first one, the easiest one, is usually gas usage. And here you're actually seeing, and if we have the time, I'll show you this interactively as well. Here we see something we call the gas profiler intentionally. So it's looking at how much gas a particular transaction has used, and this translates into the business value where we know how much gas or how much BNB, in the case of Binance Smart Chain, a user needs to spend for something to happen, but also to be sure if the transaction can actually finish, that we're not using too much gas and things like that. Optimization comparison. So people usually use proxies for this. So we deploy a new version of our smart contract and we cannot be sure if it's using too much or too little gas against something else that we made. We can do an optimization like, yay, we got the gas usage down by, I don't know, 50%. But until we actually deploy it and start using it and start testing it, we cannot be sure when we're testing locally if that is the case. So comparing different optimizations is a really good way to see if we're saving our users money and bringing business value. Protocol version comparison. We all know that most protocols around each 1 or 2 years deploy a new version with new features, usually gas savings and things like that. It's really important to see if users are starting to use the newest version. For example, on the Ethereum mainnet, when Uniswap deployed their version 3, they were really keen on knowing if the version is better than version 2 by measuring how much money people locked in version 3, and then again, how many people are actually using version 3 against version 2. So when you deploy a new version of your project, it's really important to see if people are actually migrating or using the old version. Incentive comparison. Looking at here is something called the gas station network. They basically pay for users' gas so people don't have to waste money on gas. That's something called meta transactions. I won't go too deeply into that. But as most of our protocols have economic incentives, so the systems can be working, monitoring and plotting and looking at if those incentives were correctly assumed by us. So if people are doing in the system from an economical perspective what we actually wanted them to do, it's really important to measure that, because if something isn't working, we should probably tweak some parameters or get back to the drawing board and start working on the next version of the protocol so we can fix it. Emitted events, this is an easy one to set up. So just by looking at which contracts are emitting which event, really important, we can see huge spikes. For example, on AMM, we can see a lot of swaps from a particular address or a lot of swaps in a particular time of day. This can be like a generic type of thing to measure, but when you come and see it and you know your protocol by heart, a charge like this can actually tell you how the system is working and should you sleep or should you fix something. Another one to see the emitted events is the same thing, but not plotted over time, but we call it the leaderboard. So which events are being emitted the most, and it's another view on the same thing. Function calls are a similar thing, but they demonstrate something different. We can see if somebody's calling some function more than another one, and this is important for something called outlier detection. So if somebody's calling a particular function thousands of times more than another function, that can mean that somebody is trying to exploit something in their system. So from a security perspective, looking at this, again, it can usually be just a lot of noise and nothing useful. But when it's useful, it's really useful to know what's happening. And as I mentioned, outlier detection. So here we have the top callers in the last 7 days for a couple of contracts. Here we can see if somebody's using their contracts more than other people. We can start identifying bots, we can start identifying power users, or we can start identifying a hacker trying to exploit your protocol by calling, for example, a lot of small transactions. So if you want to remember anything, again, to reiterate from this whole presentation, is that you should start monitoring from day one. The next one is that it's important, even though we're engineers, to focus both on the business metrics and the technical metrics in order to succeed, and to be proactive, not reactive. So that's the one. The third one is the most important one. So you should think about how something can fail or what it means for something to work, and you should set everything up to basically check your assumption if it's correct, and if it's incorrect, to see what you can do about it. So that's the end of the presentation. I'll stop it now just to see how much time we have. Julian, I think we have time for the demo. I don't know if you agree.
Hey, yeah, sure. I mean, how about we answer some questions first, and then we maybe spend maybe 5-10 minutes answering some questions, and then we do a short demo. I'm afraid the audience might be really too bored. So great. Thanks for the presentation. I think it's really informative, especially for people who are developers and non-developers. So really thank you for that. So the first question is, I guess for people who are on this call, I'm assuming most of them are developers, and some of them might be considering even developing their own monitoring system. What would you say? Would you recommend someone to make their own monitoring solution?
Sure. So it's one of those questions where I like to answer with the question first, would you make your own database? So I think in the year 2021, if somebody came to my team and told me, we're not going to use something that has been proven to be working for the last 30 years, like, I don't know, MySQL, I'm not sure how long it's been existing, but let's not use a SQL database. I can write this one on my own during the weekend. You would probably think that person is crazy. So it's a similar thing with the monitoring system. You can get, to some extent, value from your own monitoring system, but at that point, you need a team to work on that monitoring system. So it's really hard. Huge organizations do have their own, but in the blockchain space, we see teams that aren't that big. And that's actually really good. I think the space is moving fast because you have 5 people making something that before would have taken like hundreds of people to make. And people building on top of the blockchain don't have the time, nor they would have should make time for it, basically, to make their own monitoring solutions. You should use battle tested, proven things to monitor your system is working as expected, and then focus on your business and engineering your smart contracts.
Okay. Well, I mean, would I make my own database? That's a really tough question. Frankly speaking, I would say personally, I think my personality is a bit more on the conservative side, so I would definitely would like to use something that has been proven in the last 20 years, right? Yeah, but oh well. Okay, next question.
So it's a fun weekend project, definitely. It's definitely a fun weekend project, but a tough one.
Okay, next question. So would you say there is a thing as too much monitoring, or do you think that there never can be too much monitoring?
It's one of those yes and no questions. So I remember when we were starting out in the Web 2.0 companies, and we were reading a bunch of blog posts around how you should do monitoring, alerting, and everything else. The thing my friend and I did is we instantly wasted 2 weeks to add alerts for everything. But the problem with having monitoring around everything and alerts for everything is one of those cases of you don't see the tree from the forest. So you get too much noise, too much alerts, and what developers then usually do, and I'm guilty of this as charged completely, is they mute channels with alerts because you're getting tens of messages per minute or per 10 minutes. So if everything is constantly screaming at you, nothing is actually screaming. That's like the norm. So there is a thing as too much monitoring, and getting like the sweet spot is hard, but it's one of those things you need to know your product inside and out, and then testing what works for you.
Okay. Last question that I have. So, maybe I think you already covered this, or maybe you haven't. But what are the 3 most basic alerts a project can set up today? I would say that would still bring value. I know that there's a lot of monitoring systems nowadays that has quite a bit of alert, like you just brought up as well. Sometimes there is such a thing as having too much monitoring, right? So, what would you say that if a project already has monitoring systems in place? What are the 3 most basic alerts that they can never have enough of, or if they already if they don't have it, what is it that they could set up today and would still bring value?
Sure. So the first one, and this is one specific for the blockchain, and that most people set up instantly, is notify me when a transaction fails. So in our world, it's quite easy to know that something isn't working because the transaction just doesn't pass. The first one and the most useful one, especially for a project starting out, is tell me when something doesn't work so I can check why isn't it working. Is it my fault? Did the user screw up something or stuff like that? So that's the first one. Then the second one, which is also a useful one, we have a bunch of bots that are keeping all of these networks and protocols working. One of those is checking that the balance doesn't go to 0. Again, it's a really easy one to set up. So if I have a bot that needs to do something every 5 minutes, so to submit a transaction on the chain every 5 minutes, I want to be sure they have enough BNB in the case of Binance Smart Chain that it's still working, because we had users come and they tell us, oh, our bot hasn't failed for the last 12 hours, and then they go, but it didn't make any, it didn't make any transactions. That's why it actually didn't fail, because it didn't have enough money. So that's the second one, which is really useful from the perspective of bots. And then the third one, and this one is more of a morale boost type of alert to set up. It's when somebody sends tokens or BNB to your address or to the address of your contract. It's really nice to see value coming into your project and see that people are using it. So that one is useful to see that people actually are using the thing that you built. So it's sort of a heartbeat, but it's also a really good morale boost to see money flowing in. So yeah, those are like the first three I would set up probably.
Okay. Well, I mean, thanks for that. Like, I would say that sometimes, in terms of having those monitoring systems, even with smart contracts, sometimes people do actually forget the most basic things that they should have. So, thanks for bringing up that. I think it will serve as a very important reminder for any of these developers who are actually developing their own smart contracts or introducing monitoring systems as well, right? Yeah. Okay, so. Let's stop for now. Maybe you could share that demo that you were talking about earlier. And then after that, if we still have a bit of time, let's carry on with more questions.
Sure thing, no problem. So I'll try to make this demo as brief as possible and as less sales as possible, as I usually hate those demos. So I'll be demoing this to you as one engineer to other engineers, and not as someone who's trying to sell you anything. So again, I'm going to share my screen, and Julian will just have you tell me if you can see everything. So do you see a purple bluish screen and tenderly up left? Awesome.
All right, got it. So I'll give you the time, and yeah, please.
Great. So everything I'm going to show you now, you can use for free on Tenderly. So Tenderly has the best free tier in the space, maybe too good if you ask me as one of the co-founders, but and I'm joking like that. So when we started building Tenderly, we are engineers. We really like free stuff, and we've built everything in Tenderly for it to be free to use while you're developing, and then we only charge for the collaboration things. So if you're working with someone and your project grows, that's when you need to start paying. But everything that you're going to see, the most powerful tools in the space that I'm going to show you now, is completely free. So I'm going to create a project that's called BSC Workshop Demo. So a project of Tenderly, you can think of it as this sort of folder structure where we can add our smart contracts and start monitoring them. Now, To add a contract, you click here, and I already have here 3 addresses set up. So you can add your contracts to Tenderly via our CLI, which is a command line tool. We have plugins for Hardhat and a couple of other frameworks. And then you can also upload from your browser something similar to Etherscan. But what we actually do is that we connect to BSC scan. So you can just paste in an address. And then if your contract is already there, Tenderly can pull in all of the data that it needs. So I'm going to add 3 contracts just so we can play around in this demo. So I have a pancake pair from PancakeSwap. I have a lottery game that I like to use to demo stack traces. And then finally we have the Smart Chef contract. So when I click import, it takes like less than 2 seconds. And we go to the transaction screen, which is something similar you would expect from BSC scan, but it actually shows aggregate from all of the contracts that we have here. Again, PancakeSwap being very active, we will see only those right now. But let's see, for example, what the lottery contract is doing. I can filter here, and then instantly I can see that the draw function is failing. So if I would go here, and this was actually one of the first features of Tenderly 2 years ago. It has much evolved since then. We can see that the error message is the BEP20 error of the transfer amount exceeding balance. But here we can see a stack trace that you would expect from a programming language in year 2021. And what's even cooler, I can go into debug error here, and I have a fully fledged visual debugger. I can step through things. I can see the input variables. I can see the output variables. I can see the data that's there. I can see state variables if state is accessed in a particular spot. And then I can see, oh, if I go way down, aha, okay, so B was probably larger than A. That's why it failed. And then I can go one way up. I can see, wow, B was actually greater than A, and that's why it failed. And I didn't waste hours debugging the transaction. I did it in like, what, 45 seconds. But let's go to a transaction that succeeded. Let's use this one from PancakeSwap. So we can see the usual things you would expect, so tokens transferred, but here we actually see the whole overview of the transaction and what happened. I can click on each part. I can jump into the debugger if I want to see what's happening. Again, as we have this whole money Legos analogy happening in the decentralized finance space, we can go to the contracts tab here. And then if I go back to the contracts, we can see all of the contracts that participated in the transaction at a glimpse. We can see the events that were emitted. And then again, we are humans, so this isn't human readable. This is at least human readable to a blockchain developer. Here, the WAD is a good one, as you can see, because this means nothing. This means nothing. And this is something that we can actually perceive as human beings. So we can see all of the events decoded in a human readable form of what happened. Same thing for state changes. So here we can see that these state variables have changed from this value to this value. We can see even mapping. So for example, the balances of the BEP20 token, we can see it for each particular address, how much it has changed. The allowances, for example, and we support deep mappings, and this is really interesting. And then finally, the gas profiler that we saw during the presentation, where I can just click around and have a deeper dive into what my contract is actually doing. And this is one of those metrics that we have been talking about. So actually seeing what is spending how much gas, and then while working on optimizations, I can see how it works. Now, I will point to you into the direction of a really interesting button here. It's called Resimulate. So let's click it. Here, we can actually see something really interesting. Or, sorry, let's even pick a better. Let's do a direct transaction. It can be even more fun to demo like that. So if we pick a direct transaction, here is an approve. Yeah, let's do this transfer here. Here we see somebody transfer something over from PancakeSwap. Let's see it load. So this is a normal token transfer, and we can see the inputs that it should be sent to this, and it was sent from this address here. If I click Resimulate, we will actually see something called the Tenderly simulator. So the simulator is a way for you to change parameters of historical transactions and test out what would have happened even without submitting them on chain. So here I can see the pancake pair, the transfer event being called, the address that was used as the destination. And if I do just simulate, the same transaction will happen. So it doesn't have gas now, actually. But if I change a particular parameter, we will see that it did or didn't work. Another interesting thing that I can do run simulation here. Let's pick our, I don't know, smart chef over here. And we can do deposit. And let's deposit 1,000. I don't know 1,000 of what this is. But for the from address, let's use, let me pick the address that we have here, or actually, sorry, I have it here. So let's pick this one. And then we can see use pending block. So I can actually see what would happen in the next block if I submit the transaction now. Again, without spending any gas. And here we see that it's the ERC20 transfer amount exceeds the value. We can see that, exactly where it failed. And we did all of this without submitting anything on chain. That was the simulator. We have forks as well. Forks are a way to instantly fork a network and try stuff out without actually having to run a full node next to it. So let's do BSC demo fork here. I can even pick, again, a historical block. Let's do this one at the transaction index of 200. So here, I instantly created a fork, and now I can change simulations, just like I did in the last part of the demo. And we can chain multiple simulations and see what would these complex transactions do between each other if we do submit them on chain one after the other. Local transactions is the same thing, only while you're developing locally. So it's really interesting to save time with debugging, gas profiling, and everything else, although we won't spend too much time here. And now we're coming to the monitoring section. So the network section is more of the networks that we support, which is a lot. So we support the Ethereum mainnet, all of the Ethereum testnets, RSK as a smart contract enabled chain on top of Bitcoin, POA, XDAI, and Polygon. And then, of course, we are on the Binance workshop, so we support both the Binance mainnet and the Binance testnet as well. We have the analytics screen, which we did some parts of during the presentation. Here is like the default dashboards that we give you. So we already did think about some metrics that might be interesting to you guys. So if we go here, I'm guessing one of the most interesting ones can be the daily active, weekly active, and monthly active users. And because we're having PancakeSwap here, this will take some time to load this. They have quite a lot of users. But here we can see transactions over time, how many successful versus how many failed transactions, the events that were emitted over time. Again, top callers, here we can see this particular address doing 54K transactions in the last 7 days, which is a lot. And this is still calculating. As I mentioned, we have PancakeSwap here. But let's create a graph to see how powerful this is. So let's do, for example, give me the average gas used for my contracts, and let's do it per function in the last 7 days, and let's do it by the hour. And you'll see how crazy this is, but we instantly get all of the data that's needed. So here we can see that the burn function is using like 150K gas. We can see the mint using the same. And here, I mean, we can go around and look at a particular one, even exclude some of them if they're bringing a lot of noise. We can also see this, for example, as part of, I don't know, a bar chart, which isn't useful for this many days, but let's do it for the last 24 hours and see it that way. So that's an interesting one. Again, stack bar chart. So all of this can be really interesting, and we can save this here, gas used, and when we create it, we will see it added down below with the rest of the graphs. And then finally, we come to the alerting section. And then again, just for everyone to remember, all of this that I'm showcasing, you can use now without adding any credit cards, paying in crypto, or whatever. Finally, we come to the alerting section, which might be one of my favorite features. So here we have a bunch of alerts. So the one that I mentioned would be the failed transaction, and you can just add your contracts, pick failed transaction, click on project, and pick any of the channels that we support. So we support email, Slack, Telegram, Discord, Sentry, and PagerDuty. And pronto, you have alerts set up for your project. But let's do something even more cool. Let's do event parameter for a particular contract. Let's do pancake pair. And then if there's a transfer event whose value is over, let's say, I'm not sure how many this is. I think this is around like 1 pancake token, but this, notify me on my email and my Telegram bot, or even better, let's use this. And then when I click save, it instantly starts working in real time and monitoring if everything, if any transaction has an event that matches this criteria, I'll get notified. Another one that I'll show, and then I'm quite sure I'm done with the demo, and then we can go back to questions if we have any, is, for example, this is the most complex one, the state change. So again, let's pick the pancake pair here. And then let's say if the total supply changes by more than 30% in a single transaction, notify me. So as you can see, the alerting system is really flexible. It can do simple stuff, like notifying when there's a successful transaction, a failed transaction, somebody calls a function. But you can really take a huge deep dive there. And when you know how your system is working and how you expect it to behave, you can even inspect state or event parameters and see if everything is working as it should. And then finally, you have collaborators. So if you're working with someone, you can invite them to your project and you can debug and do all of this together. So that was a brief demo. Julian, I'm here if you had any questions.
Not really, Bogdan. Hey, Bogdan, I think we still have a bit of time. Do you want to run through the start of the demo for the viewers? Because I think just now when you started presenting, you forgot to actually share the screen. So they were just looking at you talk, but they couldn't see your screen.
So everything I did was just me without any screen?
Only at the start. Only at the start. I think for 5 minutes or something like that.
Sure. Okay. This was like a drama. So I hope I'm good enough of an actor that you got the idea of how everything is working. So do you see the screen now?
Yes. Maybe you could. I think you started showing with how to call create the smart contract and that kind of stuff. And then I think I think I only realized that at like somewhere after the first 25% of what you were trying to
just to check,
and I realized that it wasn't that.
Sure. So just to check, is this the first thing that you saw? So me coming here and pasting the addresses?
No.
So you didn't see this at all?
Exactly.
Okay, sure. So as I mentioned, we created a project here in Tenderly. I'm not going to go through that first, and then Julian, you can stop me from the part that you saw. So here I pasted in the address. So as I mentioned, you can upload via your browser all of the contracts or the whole directories that contain your contracts. You can do a CLI upload. So we have plugins in the CLI, which you can programmatically, for example, from a CI/CD pipeline or wherever from, upload your contracts. And then here I pasted the address. We fetch the data from BSC scan. So if you verified your contract there, you're good to go. And I have 3 contracts here that I've prepared. So one is a lottery contract that we have here. One is a pancake pair. And one is the Smart Chef here contract. We clicked import, and then, as I mentioned back then, again, less than 2 seconds in, the contracts are added. So if we go to the transaction screen now, we can see an aggregate view of all of the transactions that are happening in the project. Now, Pancake Swap is a very, very, very active protocol. So we can only see the pancake pair here as there's a lot of stuff happening. But I can, for example, use the lottery contract that we had here. I can filter the transactions there, and I can see that the draw function is failing when it gets called. So I'm going to click here. And again, as I mentioned, this was one of the first features of Tenderly that we shipped 2 years ago, which is stack traces, which you would expect from a programming language in this year. But here I can just jump into the debugger and see, it's failing on this line, so B must be greater than A. And then if I go to the previous stack frame, I can actually see that correct. B is more than A, that's why it's failing. And I debug the transaction, less than a minute, instead of wasting like tens of minutes or even an hour to see what's happening. And then we went back to the transaction screen. We can pick a successful transaction, which is much easier, much more interesting to look at. Here we see tokens transferred, but below we can see the overview of everything that can happen. I can even click on a particular part and like view it in the debugger. And then again, we call this the visual debugger. So this is something that you would expect from a tool like this one. Here we have all of the input and output variables, state variables, if they get accessed in a particular place. Here we have only inputs and outputs. We have all of the contracts that are, let me go here up top, all of the contracts that are participating in a particular transaction. So that's an interesting one as well. We know the money Lego analogy, so we can see all of the money Legos here that are participating. We have human readable decoded events. So for example, here, this is how it looks like on the blockchain, and this is how it looks when it's decoded in something humans can read. We have the state changes here, which again are human readable. So you can go through here and see how the state changed for this particular transaction and see if something isn't working as expected. And then finally, we have the gas profiler here as well. So we can deep dive here and see how much each function is using gas. And this is really important because if you remember from the business perspective, it's really important for users to spend as less money as possible to use our products, our contracts. So this is like a great view to see if we're doing our best when it comes to gas optimizations. Julian, just a question. Did the people see the simulator, or I can go through that one for the next like 2 minutes and that's it? So it was this.
I don't think they actually saw this.
It's okay. So I'm going to do this one.
I think they actually saw this like midway through, because this kind of looked
familiar.
Maybe you could do this. Yeah. Oh yeah, they did see the simulator.
Okay, sure. Then I can stop showing the screen. If we have any questions, that's good. I don't like repeating myself, but I know people find boring people that repeat themselves. So if you have any questions from the stream, I'm here to answer them. If not, I'm really happy with the presentation.
I haven't seen any questions. Maybe for anyone who has a couple of questions, we could wait a few minutes to see if any questions come up. Else, I think this is probably it. So while we're waiting, I just really wanted to thank you for your time, Bogdan. It's really great having you here today. I'm pretty sure that, in terms of the community and all that kind of stuff, I think a lot of people has been actually wanting to understand more in terms of the DeFi security and what projects might be able to do, the steps that they are able to do and take in order to ensure a certain level of security, and how users' funds, can then be secure, right? Yeah, exactly. In lieu of all the happenings, the attacks and all that in the blockchain crypto space, what you guys tenderly and the other audit security firms that we have had over the streams over the past few weeks, any of those partners, their work is very, very much appreciated. And that's how, when consumers, their funds was being saved, right? Only that we're able to actually foster this really good crypto adoption, as well as this entire industry that we're both inside, right? And it really sucks when you wake up every morning and you see like a piece of negative news. This protocol gets hacked again, and that protocol gets hacked again. It's never a good feeling. So
no, it's horrendous. It's a horrendous feeling. I mean, I think we have like an internal counter here. Like whenever there is a week without the hack, we reset the counter to 0. But we haven't, unfortunately, reset the counter for a really long time. I mean, almost every Monday or Tuesday, we wake up and see like, fuck, somebody like during the night lost like $10 million in funds. It's really hard. The space is very young. There's a lot of money in it, so it's a really interesting place to develop, but it's also a very adversarial environment as well. So it's really important to do your best to save the funds of your users.
I agree. Okay. I don't see any questions on the
Sure.
comment section, so I guess this is it. Thanks for your time. I mean, the entire
Thanks for having me.
walkthrough in terms of the simulation and all that, those are fantastic. So thanks, Bogdan, and everyone, thanks for tuning in. Thank you.
Thanks for having me, all. Bye.
You're welcome. Bye-bye.